Hello, my name is Evie, and I'm a second-year engineering student studying creative technology and design at the University of Colorado Boulder. Today's lesson is all about simple machines, and I have HelperBot here who knows a lot about machines to help out. HB here is a machine, that much is true, but they're not the kind of machine we're talking about today. No, we're going to be talking about much simpler machines, the ones without electricity or internet. We're talking about machines that people used back in the day to build large buildings and structures. Let's say someone came up to you and asked you to build a super large building. The only catch is that you didn't have any complex machines or tools like huge cranes, automobiles, or screwdrivers. How would you do it? Well, there are 6 simple machines that we made for ourselves long ago. These machines helped us build things we couldn't have otherwise, like the Great Pyramids. They are as follows: wedges, wheels with axles, levers, inclined planes, screws, and pulleys. Pretty simple, huh? Much, much more simple than a sentient AI. Let's go over what these machines do and what they look like. First is the wedge. It's a simple machine that often pushes materials apart or cuts things. It can range from bulldozers to doorstops to scissors to axes or knives, all a mixture of simple and complicated machines. Second is the wheel and axle. They make things easier to move by rolling and increasing the distance of motion, which reduces friction. Some examples are cars, bicycles, or wheelbarrows. Third is the screw. This simple machine holds things together and turns rotation into a lengthwise movement. Bolts, clamps, jar lids, car jacks, and of course screws are all examples of this. Fourth is the pulley. It makes lifting things with a rope much easier by redirecting force. There are many pulley systems, like flagpoles, elevators, cranes, and rock climbing gear. Fifth is the lever. It helps lift heavy weights using longer distances. Some examples are light switches, seesaws, and bottle openers. Sixth, and finally, is the inclined plane. Inclined planes make it easier to move objects upwards. It's typically a longer path, but it makes it easier to lift things. Examples of this could be stairs or ramps. Did you know that you can combine several simple machines to make more complex or compound ones? For example, a car jack combines both the wedge and the screw. It pushes the car off the ground by twisting it to go up and down. A crane combines a lever and a pulley, lifting heavy weights at long distances. A wheelbarrow combines a wheel and axle with a lever. You can hold the items in the bin from a distance, giving you leverage while the wheel and axle helps you move it around. And finally, the axe combines the wedge with the lever, allowing you to forcefully separate objects like wood from a distance, giving you more leverage so it's easier to do so as well. These complex machines can all work together to make our lives easier. What other simple machines do you think you can combine to make a more complex one? All of these simple machines provide us with a mechanical advantage. A mechanical advantage is where the amount of work someone has to do is reduced. Oftentimes, you have to apply force over a longer distance to get a mechanical advantage, but it makes the task much easier. For example, taking the stairs instead of a ladder to get to a higher level is easier, even if it is a little slower or is a longer distance. People in ancient Egypt also discovered this mechanical advantage by utilizing simple machines. They used simple and complex machines in order to build the pyramids, something that they couldn't have done otherwise without them. Having simple and complex machines to build what you want is only one part of being an engineer, though. You also need the engineering design process, a series of steps that engineering teams use to help them solve problems. The first step is to ask. You need to identify the problem and the needs of the situation, as well as the constraints. What is the problem? What do you want to do? What are the requirements for the project? What are the limitations? Who is the end user? What's the goal? Things like that. All of these questions are essential to ask as an engineer. The second step is to research the problem. You need to gather information and research what others have done beforehand, so you have a basis to start from. You also need to talk to people from many different backgrounds and specialties so you know what technologies are available and how different viewpoints may affect what you create. You wouldn't want to create something for someone, then realize they don't actually need it in the first place. The third step is to imagine and develop possible solutions. Working with a team to brainstorm ideas and develop as many solutions as possible is a good approach to this. It's a great time to give as many ideas as possible without any judgment. Building on each other's ideas is great too. Remember to stay focused and listen to other people, though. Good design involves good teamwork. Huge projects like pyramids or skyscrapers only succeed when people collaborate and share ideas. The fourth step is to plan, where you select the idea you think would work best. It's good to revisit the needs, constraints, and research from earlier steps so you can compare it to all your ideas and find out which one is the best fit to move forwards with. You can combine ideas as well, mixing and matching aspects of them in order to get a good solution. The fifth step is to create, where you build your prototype. Now's the time to move forward with the plan you put together. Building the prototype makes your ideas real, and the early visions help you and your team decide if the prototype meets all the requirements of the problem you're solving. Being creative, having imagination, and aiming for excellence in design is very important in this step. The sixth step is to test and evaluate the prototype. The most obvious question is, does your prototype work? Does it solve the need or problem you were trying to solve? It's good to get feedback for your prototype, even if you think you don't need it. Analyze it. Talk about what works, what doesn't, and what could be improved. The seventh step is to improve and redesign as needed. This is where you talk about how you can improve your solution, make revisions, and draw new designs. In order to make your product the best it can be, you need to iterate through it over and over again until you have the best possible solution. From there, you repeat the process all over again, iterating until you have a product that you think is best. With both simple machines and the engineering design process, you can create just about anything if you put your mind to it. Engineers are constantly working on ways to improve people's lives, utilizing simple and complex machines in order to do so. Engineers are problem solvers, inventors, collaborators, and creative thinkers. They use their knowledge to design buildings, bridges, equipment, machines, tools, and many, many other things to solve problems and help people out. What problems will you solve? Anyways, that's all for today. Thanks for watching, and we'll see you next time. Check out the full lesson on the TeachEngineering website. Then, check your knowledge of the 6 simple machines and utilize the engineering design process in modern-day pyramids.